In today's lesson, which is on page 316 in your workbook, we will be actually looking at how to find an equation if we are given a vertex, so the point P and Q, and any point on there, which is, let's say, any x or y. How are we going to get an equation from it? So that will be the main concept. Along with it, we will also look at how to find x-intercepts and y-intercepts using that form. Now, before I actually go into teaching this concept, I just want to remind you guys about things that you already know. So you know that an equation of a line is this. So we're going to just start with a simple line one because everybody's more comfortable with that. We know that to make this equation, one way is to create a table of values, and you can then plot them and connect, and you get this equation of the line here. Okay, so when we look at these points, what does that mean? That if I were to put in -3 in this for x, my y value would then come out to be -7. So that's what this coordinate means. That's how we get them. That means -3 and -7 for x and y actually work for this equation. They are the ones we got by actually using this particular equation. They will not work for, let's say, if I have another equation, if I just change it even slightly, if I were to put -3 in there, are we going to get -7 for that equation too? So let's see. If I change that, I don't get -7. In fact, if I put -3 in this particular equation, it gives me a different y. So every point that you see in the table of value is unique to this particular equation. It works. It's a solution for that equation. So I can find that point on the line here somewhere. Okay, so that's the idea, that when we have these set points, you can even look at points that are in between. So I could look at fractions or decimal numbers in between, and that will give me a very unique y value for it. So every single point that is a coordinate here can be known as a solution to your equation because it makes your left-hand side equal to the right-hand side. I can try any point here. So even if I want to try this one, let's say, if I were to put 3 times 1, it should give me 5. And if you work it out, it does give me 5. Okay, so these coordinates, any single point on this line is a solution to my equation. Okay, so every coordinate on the graph is a solution to the equation. Okay, and that's not just for a line, it's true for a parabola as well. So any point on a parabola is a solution. It will make my equation of that parabola true as well. So that's the first thing I wanted to talk about, that you can pick any x and y point and it should make the equation of that particular graph to be true. Okay, point number 1. The second thing that I want to talk to you guys about is what does the value P and Q represent in the equation. So you'll be dealing with this form of the equation as we saw that in the class. We looked at the vertical and the horizontal translations. So remember, the vertex comes from this value P and this value Q. So the P and Q here are the vertices of this particular equation. So remember that point. So this is just another x and y value on the graph, but it's very special x and y value because it represents the vertex. So if we have a graph like this x and y value, they are x and y, but we call them P and Q because they represent a very, very important part of your graph. So remember those 5 things we learned about a graph, and vertices was one of it. Okay, so even though they are x and y, we call them P and Q in there, and that's why they have their own variable in the equation. So having said that, what we are going to do then is we're going to find the equation from this idea, 1, that there's a vertex P and Q, and 2, that there any point on the graph is going to be a solution. So we're going to combine these 2 ideas, and the steps for that, and I'm going to show you them, they will make more sense to us than when I actually do the question. The steps are that you replace the P and Q with the coordinates of the vertex. So in the equation that we start with, that's this one right here, the first thing you do is replace the P and Q with the vertex because they will give it to us. Then we will look for another set of x and y, and we will replace it with x and y. And what that will give us will be an almost complete equation. The only thing missing that we don't know is this value of a. That's part of the equation, right? So that's when I call it a partial equation. But to find it, we will solve for this a. And once we have that, we will come back and we will write the complete equation. Okay, so let's take a look at that, and by looking at an example.